In this video, I will give you a short introduction to the HAExplorer, which is a system we developed for the analysis of biomechanical motion data. It takes as input a sequence of marker positions or rigid transformations that describe the motion of different objects in a scene and then allows you to compute, filter, and compare the helical axis of motion of these objects. So the HAExplorer lets you explore motion using the helical axis method. Once a dataset is loaded, a helical axis set can be created for any individual object. This is as simple as selecting at FHA world and then choosing any object in the scene. The helical axis is automatically computed for every time step in your data. We use an arrow glyph to display the location and orientation of the axis for every time iteration. You can replay an animation of the motion, during which you will see how the helical axis of the selected body changes over time. In each time step, the body rotates around the displayed arrow, following the right-hand rule. This is nicely visible here. When the spine flexes forward, the arrow glyphs point to the right, and when it turns around, the axis point into the opposite direction. The time window of visible glyphs can be easily resized or shifted, which allows to select and view a specific sequence in the whole motion. We can also modify how the glyphs appear in the world and pull them apart on their axis to make the scene clearer. The helical axis over time changes position, and as you can see, it traces a surface, which can also be visualized if needed. So you can see the continuity a little bit better. The color that you see in the glyphs and on the surface is a gradient that is mapped to the total time range of the motion. You might have noticed that is also shown here on the time slider. And this mapping helps to identify what happens when in the scene, even if you're just looking at this static representation. If you need to replay a specific sequence of the motion but don't want to change the time window, we also got you covered. So selecting live view right below the play button gives you the ability to hover over the timeline and control the active time this way. You see the highlighted glyph is the helical axis that describes the motion at its current point. This gives you really granular control over the temporal dimension. On the right, you'll find a scatter plot and two line plots, which show the quantitative components of the helical axis, that is, the amount of rotation and translation that happens at any given point in time, or more specific, the rotation and translation velocity. The scatter plot shows the correlation between these two quantities, so we just map the location of every discrete data point, and the line plots show the rotation velocity and translation velocity over time. And they give a really precise impression of the numerical values and clusters or components of the motion. You can also zoom into these plots to get better readings, and they share a time axis, so you can always compare the rotation and translation that is happening. Note that the translational component of the helical axis can be negative, therefore we provide an option to just view the absolute translation if needed. The scatter plot also doubles as a tool to filter the attributes. We integrated this region of interest widget where you can select a data range that should be shown in the 3D view. This way you can filter out all axes with, for example, rotational velocity close to 0, so if almost no rotation occurs. And sometimes this can give you a much clearer view of the scene, and you can already tell apart clusters that appear to be the principal rotation axis of this motion. Now, for comparing objects, you can add as many helical axis sets as you need, and each will get its own color in the scene and in the graphs, which also shows up around the selected object, so you can tell the sets apart. And you can also turn the sets on or off. We provide two options for set creation. One is FHA world, which encodes the movement of the object in the world. And the other one allows you to specify a base system where the relative motion will be encoded. Now, if I remove these two world axes, I could imagine it might be interesting to see the movement of two vertebrae relative to each other, like this one as a base, and then how does the one above move. And we could compare the motion of another vertebra to, for example, the same base, like the one that is 2 above. And now we can see how they compare, how their helical axes appear pretty similar, and how the upper vertebra seems to rotate more with respect to the selected base. You can also change datasets on the fly. For example, here I have different motion simulations of the same objects, and the parameters, the scene settings are all retained, so you can do quick comparisons of multiple datasets as well. Any helical axis created and filtered with the HAExplorer can be exported as text files, and you can select if you want the time window and the attribute filter to be applied. And then all currently visible axis sets will be exported. That is, we create one file for each parameter. That concludes the overview of the HAExplorer, and I hope that you enjoyed our quick tour.